A. Now it is a simplified formula, and this came from actually covariance. Covariance, we can use the formula here, and the standard deviations has formula like sigma x. We know actually sigma x equals to root over of x minus summation x minus x bar whole square by n. Now similarly for sigma y. Now in case of sigma x and sigma y, there is n in both the numerators. Okay. Now so obviously from root over, both the n's will come out and it will be cancelled out with the n in the numerator. Okay. Now this is a simplified form of the correlation coefficient. It is sigma xy minus 1 by n sigma x into sigma y by root over of sigma x square minus 1 by n sigma x whole square into root over sigma y square minus 1 by n sigma y whole square. Now this is the assumed mean method. That means if we assume that the mean of x is a and the mean of y is b, then we can assume that u is equals to x minus a and b is equals to y minus b, and similarly we can use this formula, and we can say that both the structures are same. In place of x you write u, and in place of y you write. So now I am going to start regression. Okay, so now let us introduce what is called regression. Regression means it is a statistical method through which we can estimate one variable, value of one variable when the other variable's value is given. Okay. Now let us see these scatter diagrams. These are called scatter diagrams. Okay, you can see there are 4 scatter diagrams. Okay, so in this first scatter diagram we can see that here there are some dots are there. You can see that, but we cannot estimate how they are varied. They are haphazardly plotted. Now if you see this value, this scatter diagram, we can see that it is visible that whenever x is varying, x is increasing, y is also increasing upward. Okay, y is also going upward. So this is called both the variables are increasing. So therefore both the variables are positively correlated. And you can see in this diagram. In this diagram we can see that x is increasing, but as well as y is decreasing. That is why the line is going down, the plotting is going down. So these here we can say that y and x are negatively correlated. Here also we can see that there is some correlation between x and y. And here we can see that since x is increasing, y is also increasing. Both are positively correlated. But what is the difference between this curve and that curve? Now see, here there is no correlation. We cannot say anything. But here we can draw a line. See, we can draw a line. So that means it is a line of regression. Here also we can draw a line. Okay. But here we cannot draw a line. We have to draw a curve. Okay, it is following this curve. So this implies that this is a regression curve. This is following a regression curve. But here these two are following regression line. Okay, so there is a linear correlation between these two scatter